Hi students, this is Okumar, 11th Standard Mathematics, Chapter 2, Exercise 2.12. Logarithmic function. You know that y that is equal to a power x, it is an exponential function, y that is equal to a power x. So how will you write that exponential function into logarithmic function? Look at that. Log y to the base a that is equal to x. What is in that power will be in the right hand side. So log y to the base a that is equal to x. It is an exponential form. It's an equivalent logarithmic form. For example, 3 power 4 that is equal to 81. You know very well. 3 power 4 equals 81. So how will you write this exponential form into logarithmic form? Log 81 to the base 3 that is equal to 4. The power 4 in the right hand side. So exponential form, logarithmic form. Note number 1. The exponential function a power x is defined for all x belongs to capital R. R refers set of all real numbers. A power x should be greater than 0. Positive one only. And so log, which is dot given, defined only for positive real numbers. So log can be calculated between 0 and infinity. Between 0 and infinity. Here, between 0 and infinity. That is a domain. Excluding 0 and infinity. Okay, that's why you are given positive real numbers. If a power 0 equals 1, it is an exponential form for any base a. This exponential form can be written in logarithmic form, log 1 to base a that is equal to 0. So log 1 to any base is 0. Okay. Some basic properties of logarithm. First one, a power log x to the base a that is equal to x. For all x belongs to 0 and infinity. Between 0 and infinity. And log a power y to the base a that is equal to y. Log a power y to the base a that is equal to y for all y belongs to set of all real numbers. That's the property number 1. Next one, for any x and y which is greater than 0, x and y which are greater than 0, log xy to the base a can be written as log x to the base a plus log y to the base a. It's a product rule. Xy becomes log x plus log y. Log xy becomes log x plus log y. What rule it is? Product rule. Next one, quotient rule. For any x and y greater than 0, log x by y to the base a can be written as log x minus log y. Quotient rule. Log x by y becomes log x minus log y. Next, power rule. For any x which is greater than 0, the positive value, and or small r belongs to capital R. Capital R represents set of all real numbers. Log x power r to the base a that is equal to or log x to the base a. Anything in the power that should be taken before logarithm. What is the power? R. So r log x to the base a. What rule it is? Power rule. Now change of base rule. For any x greater than 0 with a and b as bases, log x to the base b can be written as log x to the base a divided by log b to the base a. Okay, both the bases are equal. Here x, here b. So log x to the base b. Okay. One more change of base rule. Just have included log b to the base a that is equal to 1 divided by, if you write the reciprocal 1 divided by log b to the log b to the base a becomes log a to the base b. Again, log b to the base a, that is equal to 1 divided by log a to the base b. It is also change of base rule. Then remark, you just note down 1 and 2. We have two different types of logarithm. One is a common logarithm, next one is a natural logarithm. For common logarithm, base should be considered as 10. Look at the base, log x to the base 10. This is for common logarithm. Then log x to the base e, this is for natural logarithm. The value of a is 2.718 approximately. It is an irrational number. Okay. Now exercise 2.12, problem number 1. Let b, which is greater than 0 and b is not equal to 1, express y that is equal to b power x. You are given an exponential form, exponential function. You have tried this function in logarithmic form. Also state the domain and the range of the logarithmic function. Okay. Exercise 2.12, problem number 1. Given y that is equal to b power x, exponential form. For getting the logarithmic form, taking log to the base b on both the sides. So you'll be getting log y to the base b, then log b power x to the base b, which implies log y to the base b, that is equal to, there is a property, there is a rule in logarithm, power rule. Anything in the power that should be brought before logarithm. So you'll be getting x log b to the base b, since by power rule of logarithm. Okay. Which implies log y to the base b, that is equal to x. If the base and index are equal, whose logarithm value is 1, which implies log y to the base b, that is equal to x. However, this is a logarithmic form. The given one is an exponential form. The same exponential form is written in the form of logarithm. First part over. Now you have to find out the domain and range of the logarithmic function. Domain and range. Domain, already I told you, the logarithmic value can be calculated between 0 and infinity. That is a domain. So you have to mention 0 comma infinity. Look at the brackets, excluding 0 and infinity. And the range, a range lies between minus infinity and plus infinity. The logarithmic values, this is a logarithmic value, can be calculated between 0 and infinity. This one is the logarithmic values whose range between minus infinity and infinity. So domain and range. I draw the diagram. x dash, y and y dash. 0, minus 1, minus 2, minus 3 it is going on. Here plus 1, plus 2, plus 3 is going on. Here 1, 2, 3 is going on. Here minus 1, minus 2, minus 3 is going on. Log 0 value minus infinity. 0 value minus infinity. Here full of negative numbers, correct? 0 comma minus infinity cannot be plotted. So that I have excluded that value 0. Look at the bracket. So now you can calculate the value after 0. So that the curve will be like that. The log 1 value 0. Here it is. Log 1 value 0. It will be coming like this. It never touches y-axis. It is going on. It is going on. This is the logarithmic function. It never touches y-axis. So y-axis is an asymptote to this curve. What do you mean by asymptote? If this y-axis touches the curve, that is called a tangent. It never touches the curve. This is a logarithmic curve. Therefore, this y-axis is called asymptote to this curve. Okay, this is a logarithmic function. Now look at the x values. The only positive real numbers between 0 and infinity. That is the domain. Now range, look at the graph. Minus infinity to plus infinity is going on. Start from here and it is going on. So minus infinity to plus infinity. So range along y-axis and domain along x-axis. So domain once again between 0 and infinity. Range, the curve lies between minus infinity and plus infinity. Okay. So problem number 1 is completed. I'll be teaching problem number 2 in the next video. Thank you, children.